So this video is on Integrated 3, Chapter 2, D-Day number 4. So when we're graphing this very first function here, this is going to be a cubic graph. And you want to pay attention to the stretch here is a -1. So it's going to flip this graph. Our inflection point is going to be at 1 because the x minus 1 makes that 0. So that means it moves to the right 1. And then the -5 means it moves down 5. And so I am going to go to 1, -5. And that's going to be my inflection point. You kind of zoom in a little bit more for us there. And then I'm going to do the rest of it in a different color so you can understand that this is my inflection point. If I want to be accurate with this graph, I go out 1. 1 cubed is 1, and I times it by a negative. So I'm going to be down here at -1. If I go out 2, 2 cubed is 8, and I times it by a negative, I got a -8. So 1, 2, 3, 4, 5, 6, 7, 8, let's say. Okay, I'm just going to approximate. Going the other direction, -1, -1 cubed is -1, times it by a negative, +1. If I go out 2 from my inflection point, -2 cubed is -8. -8 times a -1 is a +8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to draw my graph. And it's going to be almost like it's an open up parabola to here, and then half of one, and then it changes to like an open down. It's not an actual parabola, but just kind of that shape. Okay, we say that this is concave up, and then this part is concave down. Okay, on the next one is a square root graph with a negative in front of it. So that's going to flip this graph, flip it down over the x-axis. So my vertex here is going to be -6 because that's what makes the square root underneath the square root 0, and then -3. Okay, so I'm going to go to -6, -3. And then if I want to be accurate from here, I'm going to go out nice squares, 1, 4, 9, and so forth. And take the square root and then make it opposite. So if I go out 1, the square root of 1 is 1, times it by a negative, -1. If I go out 1, 2, 3, 4, the square root of 4 is 2, but I'm timesing it by a negative, so I go down -2. From here, I go out 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The square root of 9 is 3, times it by a negative, so I'm going to go down 1, 2, 3. And so forth. Okay. And let's sketch this. And so it starts here and it's going to go like that. It looks like half of a sideways parabola. It's the bottom half of a sideways parabola. Okay, on the next one, we have 4x to the 5th, 4 to the power x minus 5, minus 6. So if you want to think about a locator point, you can think 5, -6. But the thing that I really want to pay attention to here is that -6 means my asymptote is going to be down at -6. So I'm going to draw it in blue. So I'm going to go down to -6, and I have an asymptote right here at y equal -6. Now, when we're talking about this 5, -6, 5, -6 is really here. So the way I think about this graph is if I was to come to my asymptote where it touches the y-axis, that x minus 5 is going to move at 1, 2, 3, 4, 5, which puts us at that 5, -6. So this point right here is kind of where my graph starts. And so what happens is this is where I would be going 1 away if my a is 1, a away, depending on what my a was. And then I'm going to be timesing each time by my b. So in this case, my a is 1 and my b is 4, because these equations really are y equal a times b to the power x minus h plus k. So this 4 is my b, and my a is really a 1. Okay, so let me go back to 1, 2, 3, 4, 5. So right here, this is where my 1 away is going to go. So I come here and I go 1 away from my asymptote. Then since my b is 4, that means I'm times it by 4. So if when I go out 1, since this is 1 above, I'm going to times that by 4. I'm going to be 1, 2, 3, 4 above. And then I'm going to times that by 4. So the next one's going to be 16 above. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And let me sketch my graph. So it's going to be coming here and getting closer and closer and closer, going backwards this way to the asymptote. And that's your exponential. Okay, on the next one, this is a circle. Okay, and the circle is going to have its center at -4, 0, because there's nothing going on with my y before I square it. And my radius is going to be the square root of 36, which is 6. So I am going to go to -4, 0, -4, 0, and that is going to be my center. Let me make it a little bigger. That's going to be my center, okay? And then I'm going to be going out 6. Here, I'm going to make that slightly smaller. Sorry, maybe a 4. Okay. And so I'm going to go out 6. And let me just kind of zoom in a little bit. So, okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you can just draw a circle. I'm going to grab the circle. And if I'm going to do a circle, I want to make sure I hit shift. And I'm going to start at one of these points. And then I'm going to drag it out and have the center be there. And there's my circle. This next one is a reciprocal function. So if you want to think of a critical point, it would be 7, 1. But what that 7 represents is we have a vertical asymptote at x equals 7. What the +1 is, we have a horizontal asymptote at 1. So I'm going to do my line. Okay. And so I am going to have at x equals 7. And if I want to go straight down, I can just hold shift. I'm going to adjust that because I made that pretty fat. Okay. And really, if I want to, this is, let me just move it in here so I can see this better. This is going to be a dashed one, and I can put arrows on either side if I want. And I can just do all this by hand. I'm just kind of showing you what this does. Okay, and then I am going to have a horizontal line at y equal 1. Okay, so let me get my horizontal line at y equal 1. Forgot to change that. Okay. Okay, and let me just label these. So I have this one, which is y equal 1, and this one here, which is x equals 7. And then because I have a 1 here, you can think of this as basically xy equal 1. Because that really would be y equal 1 over x if I was to get that into y form. So I want things that multiply to 1. So I'm going to come over here and I'm going to go to where my 7, 1 is. That's kind of my starting spot. And I'm going to go out 1 times 1. On this side, I'm going to go out -1 times -1. And then I'm just going to sketch the rest of it. And it's going to be 2 branches, getting closer and closer to the X and Y, to the horizontal and vertical asymptotes. Okay, on letter F, this is a absolute value graph, which has an inflection point at -1, -1. So I'm going to go to -1, -1. And then from here, you can kind of think of this as being linear in nature. So this -2/3 is a stretch, but you can think of it as a slope in this case, only for absolute value. So I'm going to go down 2, out 1, 2, 3. And same in the other direction, down 2, out 1, 2, 3. Okay, and I can keep doing that if I want. And I'm just going to grab my line. Make it thinner this time. And there we go. And there we go. And I'm going to put the arrows on it on one end. Okay, and that's my absolute value. Okay, now the bottom ones here, these next ones, we are going to be writing the equation. We're going to assume that a equals 1 unless they give us a point. Okay. And usually what they'll do is they'll actually write the point out. In this case, they did not, but you could kind of tell where it is. So this is an absolute value graph. So we're going to have, okay, we're going to have y equal a times the absolute value of x minus h plus k. And our h comma k is going to be this vertex, which is at 0, 5. So that's what I'm going to put in for my h and k. So I'm going to get y is equal to a times the absolute value of x minus 0, which really is just going to be absolute value of x plus 5. So let me clean that up. Y equal a absolute value of x plus 5. Then they gave us this point over here, which is at 4, 2. So I'm going to put that in for my x and y to find my a. So I'm going to get 2 is equal to a times the absolute value of 4 plus 5. And the absolute value of 4 is 4. So I'm going to get 2 is equal to 4a plus 5. I'm going to minus 5, so I get a -3 is equal to 4a. I divide both sides by 4, and I end up getting my a is a -3/4. So my equation, we have to write out our equation, is y is equal to -3/4 times the absolute value of x plus 5. And that is our answer. Now on the next one, this is one of the reciprocal functions. And so these reciprocal functions are y is equal to a over x minus h plus k. And I look at the asymptotes. So I have an asymptote. My vertical one is at x equal -5. Let me write that better. At x equal -5. And my horizontal one is at y equal 4. So that's going to go in for my h and k. So let me just write it down here. So I'm going to have y is equal to a over x plus 5, because -5 would make that 0, and then plus 4. Now they say if they don't give you a point, then your a should be 1. And in this case, our a is 1 if we look here, because I would be going over 1, up 1. 1 times 1 is 1. Because remember, these graphs, ignoring the left-right movement, are basically x times y equals a. So in this case, I have 1 times 1 is 1, or -1 times -1 is 1. So my a is going to be 1. And that's our equation. Okay, on C, this is going to be y equal a times the quantity x minus h cubed plus k. And we need to look to see where our inflection point is, and that's going to be here, because that's where it's changing from being concave down, we say, to concave up. And that particular point's at -6, -3. So this is -6, -3. That's going to be my h and k. Now, they did not give us a point, so we can assume our a is 1. But you can also look and see, because if I went out 1, 1 cubed is 1, and that's where I'm at. 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is just a stretch of 1. Okay. So this is going to be y is equal to a, and again, that's going to be a 1. But let me just put it like this for a second. X plus 6 cubed minus 3. And again, our a is going to be 1. So we can just go y is equal to the quantity x plus 6 cubed minus 3. And that is our equation. Okay, so to find the domain and range, what we need to remember is a domain is our x values and range are my y's. So my domain is left to right, okay? And for this, they made it look like it stops, but this does continue going, okay, forever and ever and ever and ever. So when we're looking at this, let me just get I'm just gonna get a line to visualize this with you guys. So if I get a vertical line, and I was to take this vertical line and go across this graph here, again, it doesn't end here. These really should have had arrows on. It just kind of got cut off. So this is going to be going on forever and ever and ever in both of these directions. Okay. So this is going to go to negative infinity and positive infinity. Again, they did not have the arrows here, but it did not just stop. Okay. The graph just kind of got cut off a little bit. So my domain is going to be negative infinity to infinity. And then my range is going to be my high and low. So if I'm looking at this and I'm trying to figure out my range, I'm going to be taking this and going how high up and how far down. So this is going to go down 1, 2, 3 to -4. And the highest it goes, 1, 2, 3, +4. From -4 to +4. And so this is going to be our range is close bracket -4 to +4. On this one, just kind of a sketch of this. So if I am drawing this out on a graph, what makes my denominator 0 is a -8. So I'm going to have here, I'm just going to draw it as just this green line, an asymptote at x equal -8. And I don't have a plus anything here. It's like a +0. So that means I have my horizontal one on the x-axis at y equal 0. And then if I'm thinking about this graph, because of this -9, it's really like xy equals -9, because it's really like y equals -9 over x. But I'm thinking of things that multiply to -9. So what that means is over here, if you kind of think of this as almost quadrant 1, quadrant 2, quadrant 3, quadrant 4, like this green is like my new xy axis. This is a positive times a positive. This is a negative times a positive. So this is where part of the graph is going to be. This is a negative times a negative. So that's not going to work. This is a positive times a negative. So my graph is going to be going here and here because it's a negative. So normally it would have been up here and down here, but that negative flips everything across the x-axis, okay? So if I'm talking about my domain and range for this one, my domain is going to be that this graph is going to be going, if I'm looking at left to right, it's going to go forever and ever and ever in the positive x direction. It's going to go forever and ever and ever in the negative x direction. So that means except for we have a gap at -8. Okay, so it's going to be everything except -8 because I have an asymptote there. So this is going to be, let me grab something to write with. This is going to be -infinity to -8, open bracket, union, open bracket, -8 to infinity. And then my range, let me just grab this, bring it over here. So my range is high and low. So the highest it's going to go is forever and ever. But here at 0, it's never going to reach 0 because I have an asymptote. And then it's going to go forever and ever and ever down to -infinity. Okay. So this is going to be -infinity to 0, union 0 to infinity. Again, my 0 and my -8s are open, not closed bracket, because there's asymptotes there. Okay, on this back page, so we're going to write an equation. This is a parabola, so we're going to have y equal a times x minus h squared plus k. So this 4, -2 is going to be going in for our h and our k. So we are going to have y equal a times x minus 4 squared minus 2. Then we know that this goes through the point 3, 1. So we're going to put 3, 1 for our x and our y. So I'm going to get 1 is equal to a times 3 minus 4 squared minus 2. And 3 minus 4 is a -1, and a -1 squared is 1. So this is just going to end up being a minus 2. So I'm going to have 1 equals a minus 2. I'm going to add 2, so I get a is equal to 3. So my equation is y is equal to 3 times the quantity x minus 4 squared minus 2. Again, I got that from here. And then I just needed to put in my a. On B, very similar, but we're going to draw a picture for this. But again, it is going to be a parabola. So we're tossing an egg, and let's see, it went 70 feet across, and it reached a maximum height of 24. Okay, so let me zoom in. So if I'm graphing this, I'm going to start it at 0, 0. And I'm going to have it end 70 feet away, which is going to be at 70, 0. And then halfway in between 0 and 70 is going to be 35. So this right here is going to be 35, 24. That's my vertex. So I'm going to go y is equal to a times the quantity x minus h squared plus k. And my vertex is my h and my k. So when I put that in, I'm going to have y is equal to a times x minus 35 squared plus 24. Then I have a point, and so I want to pick a point that is going to go in for my x and y. So I probably would pick my 0, 0. And again, it's going to go in for my x and my y. So I'm going to have 0 is equal to a times 0 minus 35 squared plus 24. So I am going to do 0 minus 35, which is a negative 35. And let me square, get my calculator out here. Let me square a negative 35. So 35 squared is 1,225. So I'm going to get 0 is equal to 1,225a plus 24. So I'm going to minus 24. And then I'm going to divide by 1,225. And I would just leave it as the fraction. That's going to be my a. So my equation is going to be y equal negative 24 over 1,225 times x minus 35 squared plus 24. And that is going to be my answer. Okay, on letter C, this one, they want us to complete the square. Okay, so basically, I'm going to first take my 1 and subtract it and get it to the other side. And then I'm going to be looking at my b. And what I do is I take my b, which is 12. Let me just do it right over here. I take my b, divide it by 2, and then I square it. So my b is 12. 12 divided by 2 is 6. And 6 squared is 36. So I'm going to add 36 here, and I'm going to add 36 here. So when I do this math, I get f of x plus 35 is equal to, and then this is a quantity squared. It is an x plus, and it's going to be this b over 2, this 12 over 2, which is a 6. Last step is to subtract my 35. And there you go. There's your equation in the nice graphing form. Number 2, at the bottom here, determine if the function is even, odd, or neither. So to do this algebraically, I basically want the following to be true. If I put in a negative x and I get the same as plain old positive f of x, then this is going to be even. If I put in my negative x and I don't get f of x, but I get the opposite of it, that's going to be odd. And if neither happens, then it's neither. So let's see. I'm going to do f of negative x equals 5 times negative x to the third plus a negative x. And I want to see what happens. And so anytime I take a negative to an odd, I'm going to get a negative. So it's going to be a negative 5x cubed. And then here, this is going to become a negative x. And so I want to look at this compared to this. And what you'll notice is this was a positive 5x cubed. This is a negative, so it's not even. They aren't the same. They're opposite. And this is a positive x is negative x. So the opposite of this is this. So that means that this is, oops, even. Sorry, not even, I apologize. Odd. Okay, on number 3, we're going to solve this system. These are both y equal, so I'm going to set them equal. So I'm going to get 2x squared plus 9x minus 5 equals x squared plus 5x plus 16. And when you have quadratics equations, you want to get everything on one side, 0 on the other side. So I am going to be subtracting my x squared from both sides. I'm going to be minusing 5x from both sides. I'm going to minus 16 from both sides. And when I do this, I'm going to end up with x squared plus 4x minus 21 equals 0. And I'm going to factor this. So I asked myself, what multiplies to my negative 21 and adds to 4? Well, that's going to be an x plus 7 and an x minus 3. So I'm going to get a negative 7 as one x and a 3 for the other x. So I know I'm going to have -7 comma something and 3 comma something. And so I'm going to put that in. Let's say I put it into this bottom one here. So let me just do it in orange. Okay. So I'm going to be going -7 squared plus 5 times -7 plus 16. So that's going to be a 49 minus 35, which is going to be a 14 plus 16, which is going to be a, 30. Okay. So this is going to be -7 comma 30. And let me put it in the other one. So let's say I do that in this green. Okay. So I'm going to put 3 squared plus 5 times 3 plus 16. So I'm going to get 9 plus 15 plus 16. So I get a 31 plus a 9. So 31 plus 9, which is 40. And those are going to be my 2 points. Now on the bottom section here, number 4, A and B, on 4, I am going to multiply these numbers out, these complex numbers. That's really what they are. 1 minus 6i, 5 plus 2i. And the thing I need to remember is an I squared is equal to a -1. Okay. So when I do this math, I get a 5, I get a -30i, I get a 2i, and I get a -12i squared. So this -12i squared is really going to be a -12 times a -1, which is 12. So this right here, let me write it in black, is really going to be 12. Okay. So that means I am going to get 17 minus 28i as my answer. And again, let me just take this off. It really was a -12i squared, which is going to be a positive 12. So on this one, I want to break this down, and we can break it down by prime factors, or if you can think of a square in 20. So let me do it that way because I showed you guys prime factors today. A root 20 is a root 4 times a root 5. And when I clean this up, I get a 2 times 2 root 5, which is a 4 root 5. Now let me do the second part of this, which is my minus root 45. And a root 45 you can think of as a root 9 times a root 5. And the square root of 9 is 3. So I get a 3 root 5. So I have a minus 3 root 5. And so a 4 root 5 minus 3 root 5 is 1 root 5, or just root 5. And that's your answer. On number 9, you want to get same base. So I cannot get a 27 to be a 9 to a power because 9 to the first is 9. 9 squared is 81. That's already too big. So I want to try to get 9 and 27 down to a smaller base. Well, a 9 is a 3 squared, and that's being raised to the x plus 1. And then my 27 is a, is a 3 to the third. So when I have power to power here, okay, power to power, my 3 is being raised to the second, and that's being raised to another power. You multiply. So I get 3 to the 2x plus 2 is equal to 3 to the third. And so if I have 3 to the third is equal to 3 to a power, the powers have to equal the same thing. So I set them equal. And I end up getting x is equal to 1/2. On 16, you want to recognize this. It is a difference of 2 squares. because it is a square minus a square. And when I have a square minus a square, I can factor that to an a plus b and an a minus b, where I take the square root of the first term and I take the square root of the second term. One has a plus, one has a minus. That's why we don't have a middle term, which would have been an AB in my little example. Okay. Now, the square root of 16x squared is 4x. So I'm going to have a 4x and a 4x. The square root of 9 is 3. So I'm going to have 1 being a positive 3, 1 being a negative 3 equals 0. And then by the zero product property, I'm going to set these to 0. So I get 4x plus 3 equals 0 and 4x minus 3 equals 0. So this is going to give me 4x is equal to negative 3. So x is equal to negative 3/4. I have 4x is equal to 3. So x is equal to a positive 3/4. And those are your two answers. So you want to make sure that you understand how to do all these problems without notes, without referring to the video. So you want to practice doing these before the test on block.